Welcome to the Tom Nelson podcast. I have Jim Steele here. Jim, could you tell us a little bit about yourself to get us started?
Uh, sure, I'd be more than glad to. Now, I'm an ecologist, and I'm going to make a pitch here that ecologists need to be more front and center about this whole climate debate. People like Jim Hansen, who is one of the big pushers of this whole thing, um, he studied Venus. There's no water on Venus. There's no life. There's no lake. So he doesn't understand how that's going to work. That it gets twice as much solar heating as we do. But so the only thing he had to study climates on Venus was to look at atmospheric chemistry, which is 96% CO2 on Venus. And so that's what he's locked onto. And he's had been a miserable in predicting what's going on, where as an ecologist, we have to consider a much more complex array of variables. So, where I had to look at landscape changes, how the hydrology was affected, how the past history with the 49ers and whatever were our fields. California were affected a lot by oceans, Pacific Decadal Oscillation, El Ninos, La Ninas. So when I looked at all of that stuff, you realize CO2 is, if anything, is a very minor player. And it has all these other benefits where it has more growth or the warming. I hike in the Sierras, and I would see trees that grew before the Little Ice Age are still up at higher elevations, but the cold knocked them down. So there's been a benefit there. So if I kind of give people a sense of where I did my research. So here's on the right is I'm in the Sierra Nevadas. I'm just south of the Feather River, or Feather River down, working in a broad area. Sort of below my field station is the town of Downeyville, and this is something at the end of the gold mining days. And they completely deforested this area. This area was just barren. The gold miners needed logs for to support their mine shafts. They needed logs to make charcoal, to make all their tools. And people say you're getting deaf because there's all these stamp mills and everything running in that area. So it was probably one of the most decimated places in California in the late 1800s. Well, about a mile away from my field station is this Lakes Basin area, which was affected a lot by the mining. But you can see the trees are growing back. And if you look at their age, a lot of the age of the trees are about 150 years. But what this partly gave me insight to was that a lot of habitat changes, and there's animals and insects that like this open area. When it's open, they thrive. They need a lot of sunshine. Where once the trees grow back, they're gone. But a lot of times people are doing studies, oh, we're losing animals, or we're losing insects or birds because the trees are coming in. Well, they blame it on climate change, or they blame it on, we're destroying the earth. And there's a few studies I'll refer to that have mentioned that. But what also is happening is logging and railways disrupted stream hydrology. And so I had been hired by the Forest Service to study 5-6 different wet meadows in the Sierra Nevada. And this was one, and it started to dry out. And I've been studying it for over 10 years, and we were measuring birds. We were catching them in mist nets. So we were doing sound surveys and whatever. But all of a sudden, everything was leaving. The meadow was drying, and I brought in colleagues and students, and 90% of them within a half hour said, well, this is just what global warming says it will be. It's going to dry out the land and kill the animals. And I said, you've only been here half an hour. I've been studying this for 10 years. And I can tell you, it's not that way. And I'll get to that a little more. But what it turned out was it was a railroad track 100 years ago disrupted the hydrology. And then when you have heavy rains from an El Nino, it keeps digging deeper and drying out the water table. And that was the main issue. So I was able to get a couple of grants through EPA and a few others where we restored it. And this is sort of looking at it from a different direction. But now it is a lush meadow. It's more resilient to the droughts during our last 10 years of droughts than it was during wetter years. And the birds that we have measured is up 10, 15, 20%. So that got me on this idea that, you really have to look at landscape changes pretty thoroughly before you do this knee-jerk reaction of its CO2, because if we just followed their remedy of, well, let's buy a Prius and minimize, and let's stop using natural gases, we would have never fixed this. We never would have got a more resilient meadow, a more abundant diversity of wildlife. So you got to get the right remedy. So you got to put this CO2 warming on the back burner, which is what I've been doing ever since. And at about the same time, well, this will, one of the reasons that made me doubt it was global warming is the closest U.S. historical climate network temperature data comes from Tahoe City. And if you look at just the average, you get misled on what's going on. The maximum temperature was much higher in the 30s. The minimum temperatures has been rising, but in a lot that's due to landscapes changes, urbanization effects, or whatever. I remember when Tahoe City was just a little rinky-dink place, and now it's become a big tourist attraction. And so and the other thing is, because when we were doing our wildlife monitoring, we were out before sunrise. We had to have nets up by sunrise. So we would be out there when the minimum temperatures were happening. And the minimum temperatures were below the dew point. So we would be soaking wet. My research assistants would put on rain gear. But then as you get towards the maximum temperature around noontime, the meadows would be completely dried out. So if you're looking at how the wetness is the meadow really drying out due to temperature change, you really have to break down this maximum minimum temperatures, or you're going to be misled, because the minimums were actually making it wetter where the maximums were making it drier. And you see this with almost all of Northern California, maximums were higher in the 30s. Southern California is a little different story. But it's when they talk about wildfires that we've had in Northern California, every place where those wildfires started, maximum temperatures were higher in the 30s. So there's a whole, where you just push this global warming knee-jerk reaction, it gets very misleading. And about the same time, my job as director of San Francisco State Sierra Nevada Field Campus was an environmental education as well as research station. And I had the good fortune of being able to recruit Paul Oppler, who is arguably North America's leading lepidopterist. He understands butterflies and moths and identifies, I've gone out and surveys with him. He said, oh, this is very different from the one in San Jose or whatever. He knows them to that level. And at the same time, what was being pushed was this climate change catastrophe. And the big person that was pushing it was Camille Parmesan as a study, and she was looking at this Edith checker spot. Now, the Edith checker spot has many subspecies, of which some are around the field station. So I would talk with Paul Oppler and say, do you see this extinction going on? And he said, I don't see it. So I looked more deeply into what she was saying. Well, if he understood the biology of this, this is one of the insects that needs to have open spaces where it gets lots of sunlight. The caterpillars, in order to finish their life cycle, they will crawl to the hottest places they can find, because that will speed up their metabolism. So it looked like, if anything, warming would have helped them. And in places where she has this map of the purple of where populations went extinct, and you see some are thriving and some are gone extinct. I said, well, it seems like it's a landscape issue. It doesn't seem like a global temperature issue when you have two sites next to each other with completely different issues. So I thought it was the landscape, and I was going to try to redo her study from a landscape point of view. And so I contacted her, and she said, in her paper that was in this Nature, there was no methods, there was no data to check up. And I said, well, can I see your data? So I want to redo your study from a landscape point of view. And she refused to give it to me. And says, and what you want in science is you want this give and take. You want people to be adversarial to the point of, okay, you have a good idea, but it could be something else. Let's look at it. They refuse to do that. And there's been sort of a global attempt to deny skeptics from being able to look at stuff. You just call them a denier and not allow that to happen. And then she gets she's been pushing these crazy ideas of let's help these animals move north because of global warming. It's not the issue. It's the issue was landscape changes. It was causing these butterflies to get shaded out in certain areas, because after the gold miners left, things started to grow back. There was a study similarly in England where they had the large blue butterfly go extinct. It relies on a symbiosis with ants, but the ants and the butterfly need these open areas. And when they turned to save the butterfly, they made it a reserve and prevented grazing and everything else. The grasses and the bushes grew up and they went extinct because just a little bit of change. And you had one good scientist really look at the whole thing, and they helped bring it back by making these landscape changes. So looking at that this time, I became totally convinced that this whole global warming CO2 issue was really missing the mark and really misguiding us. She's saying assisted migration. I just see Bill Gates is trying to push let's send balloons up with dust and block the sun, and nitrous oxide, which is a very minimum player. So let's stop some of the fertilizers. It's all these disastrous remedies that they're coming up with because they have a bad analysis. So to the bird thing, when I saw this study of 2.9 billion birds have been lost since 1970. And I said, I can't believe that. My work and my research, we saw most of the time the birds were doing well until the meadow dried out. And if you look because in California had lost like 90% of their wetlands since the 1800s, but we've been trying to bring it back, and we see wetland birds are doing better. So I was curious, when you go down through their data, 500 million birds that have been lost were pigeons, house sparrows, and starlings. And starlings outcompete a lot of native nesting birders. The birds are dirty birds. They're often in the cities, and people are trying to get rid of them. There's companies that evolved just to get rid of these species. But that's 1/6 of the birds they're talking about here was those birds. And I was just flummoxed that they would push it this way. If you look at two other species, had about 250,000, and one of them is juncos that we get a lot of. There's juncos almost in every backyard in my neighborhood. It was one of the most abundant birds we had in the Sierra Nevada, but they need open area. Backyards are nice because you have open area they like to get seeds off the ground. And what had happened is that in the East Coast, as people moved in and all these marginal farms evolved, you opened up this area for these two species. And then as these marginal farms were abandoned and they started to regrow and change the vegetation, these birds start to disappear. So it wasn't a matter of a climate crisis or anything. It was just this natural vegetation change that they were picking up as a change in numbers. And then they're pushing it as this catastrophe where we got to do all this anti-CO2 stuff. And if you look at Audubon has jumped on this, and they're saying that all these birds is made worse by climate change. And usually it's with a sign saying donate now. And I see tons of the Union of Concerned Scientists, World Wildlife Fund. They're sort of using this climate crisis narrative so because I was seeing different places had different temperature trends, I've been kind of following this across the country. There was a study put out by Wickham in 2013, and they found that 34% of the long-term weather stations with over 70 years of data had cooling trends. And they were mostly focused in the Southeast, as you can see represented by the blue dots. But you would see them in different places, blue right next to red, which again kind of, to me, signifies that you really have landscape issues or urbanization. And the big places are almost solid red are the really heavily populated places on the Northeast and Southern California areas. So, and again, what this, to me, intimates is you're trying to have these policies of cooling, but 1/3 of the country is cooling already. So you're only making it worse. And if you say, I'm going to stop, I'm going to minimize your heating oil as you're in a cooling trend, and we're going to make it cooler. Again, it's insanity that what's going on that way. So anyways, and then what, I try to convince people is birds migrate from the north to the south. People migrate. I grew up in Boston. Tons of people, as they get older, for their health and longevity, they move to Florida or they move to Arizona. And if you look at this sort of temperature trends between, as you go further north, the average temperature gets cooler and cooler. Well, if someone moves from New York City to Florida, they experience about a 20-degree change in temperature. And then you have people like Greta Thunberg saying, oh, people are dying because of climate change. Well, you say, well, people are moving to warmer places for their health, but somehow this notion that we're all dying from it. And if you look at urbanization that affects stuff, this is from a photo of NASA. The picture on the left is all the green vegetation, and the stuff that's a little grayish in the middle, that's where it's been urbanized the most. And then if you do it with the infrared camera, you'll see that maybe 10 degrees difference between where it's vegetated and where it's not vegetated. So if you don't make these analyses, and I think Roy Spencer just put something up on What's Up With That, showing that what they did an analysis is how much of an urban heat island, you don't have to look right at the urban heat island, but you can go out so many kilometers and see it still has an effect as you go out. So he's arguing that you got to address that a little bit better than what's been done. But again, this is what you get. Greta Thunberg, 16-year-old with tons of people listening to her. So, people are suffering, people are dying, entire ecosystems are collapsing. We're at the beginning of mass extinction. Well, for all my work in the Sierra, we're doing better. I've had wolverines out behind us, a wolverine who came down from the north.
Wow.
Wolves have come down to where we are. The trees have come back. There's just a ton of things are doing better. Here on the coast, I see more whales than I've ever seen. I can go out, drink my coffee on the shore and watch whales, where when I help lead whale watching trips, and I assisted friends that were doing it, we had to go out 10 miles to the Farallon Islands or 20 miles just to see one. So when we stop hunting, we stop destroying the landscape. All this ecosystems are doing better than they've ever been. So, and then you look at climate-related deaths. This is from an international database on climate-related deaths, that it's down to almost zero compared to what it used to be. I mean, it's really a change, but the narratives that we're getting and we're being forced to deal with, and politicians are playing on, are saying just the opposite. So I tend to get this internal rage that, boy, we're really manipulating them, and we're weaponizing natural weather events. And just to show you where I was getting manipulated, this was what I sent to my Facebook. Is my wife and I were at Arches, and because I had quipped earlier, all my pictures got this tag that you see here that's saying, well, go to the United Nations website on climate change. And if you go there, we'll have this picture of, you see, average temperature is increasing since 1950. So they cherry picked this. When I first looked at this in Utah, they knew I was in Utah, so they gave me Utah's. And when I was in California, they gave me California's average temperature. And I said, like, they know everything we're doing, and they're trying to push this one dynamic. So, it just boggles my mind. So almost every alarmist talk says, oh, we're going to have heat waves. And I think I saw you put up the same data from the EPA. If you look in the 1930s, was the worst. And it had to do with the way we caused the Dust Bowl by ripping up all the grasslands in that area. And it also had to do with ocean circulations and atmospheric circulations. So we'll look at heat waves, and I looked at, if you can have Pacifica have a record temperature and San Francisco not. So you really got to look at the whole state to say, how much is the state suffering? Well, you look at 31 of the 48 states have record high temperatures before the 1940s. So you don't, again, and that matches this 1930s. California's record temperature is 134 degrees in 1913, set in Death Valley because it's dry and the desert allows greater solar heating. You look at Florida, Florida doesn't have as high a temperature, but its record was set, back in 1931. And Minnesota and Montana up in those areas is about the same. And actually, some of those places had higher record temperatures than Florida because you had this weather event that caused this kind of heating. So, instead of teaching people what is the weather that's causing this stuff and how long to expect it, they weaponize it. But I looked at one thing, the reason you have the cooler temperatures in the Southeast is partly where you have this natural jet stream that there's a high pressure in the Atlantic because it's cooler, it forces up over the mountains. So the West often gets these heat waves, and the South pulls this colder air down, and so you have colder temperatures. You look at this, it was the heat wave they had in Europe this summer. Well, this area looked bad, but often where you have a heat wave, you have a cool wave on the opposite side because a lot of this heat is because you're pulling warm air up or pulling cold air down. But often you would just see this part to kind of create the scary stuff instead of giving you a whole sense of how the weather is really working. Now, I see the same thing in California. Most of the vegetation is adapted to fires. We have what we call a Mediterranean climate. The high pressure sets up every summer. So from June to October, we rarely get any rain. It's pretty dry climate. And so you're susceptible to all these fires. Well, to cherry pick that, they started, here's in 1950, where it was sort of the end of all this fire suppression, and look at how fires have increased. So they're cherry picking the same thing that they did with the temperatures. But if you go back further, if you look at October, back in the 30s, 20s, early 1900s, many more fires. And then you had an era of fire suppression, which were just easing up. But part of the problem is you had all this fire suppression, you caused ground fuels to increase. If you go back even further, scientists that look at in the Southwest, back to 1700, far more fires going on, and then fire suppression. So if you just use since 1950, you're given a false impression that fires really kind of, you say the world's on fire, the world's burning. Union of Concerned Scientists person just said that, these wildfires, we're on fire. It is so misleading and so manipulative, it bothers me. But I went and investigated the fire that happened it wiped out the town of Paradise. I was able to get in and we observed it. And you could see that most of the fire was ground fires, that it didn't even burn the tops of the leaves or the needles. But if it got to a house, it caught the house on fire. So people just weren't managing the ground fuels as well. If you look at the temperature, again, it was maximum temperatures higher in the 30s than it was when you had this disastrous fire. And what we try to tell people, and we had a fire almost come to the field station, but it was set by an arsonist. But you have a fire-prone landscape when you allow these ground fuels to build up. Grasses can catch fire. They could be exposed from the snow, and then within an hour of a hot summer day, they'll catch fire. You don't need a whole climate change. You just need one warm day to make that change. And then you can have the fuels carry stuff up in the trees, more embers, it spreads. So what we argue for people is you got to have a mosaic where you eliminate that ground cover, you prevent bushes from carrying fire up into the trees and whatever, and that's the way to save yourself from fires. But the climate alarmists say, well, it's drought that's making it worse. Well, if you look at the trend in droughts in the USA, what you see here is only the worst drought was in the 1930s when we have the heat waves, but there's no trend over the last 100 years. If we look at blue oaks, which are in the foothills of the Sierra Nevada, and they really register, they're very sensitive to how much precipitation. Well, in 2014, this is what they registered as the drought. In every black line that you see here that dips below this dotted blue line tells you that there was far worse droughts all the way back to 1300 when you had less CO2, when you had less temperatures. These droughts have nothing to do with global warming, but the way moisture gets transported from the oceans to the land. And that brings you to El Ninos and La Ninas and the Pacific Decadal Oscillation and everything else. If I go back 1,200 years in the Western USA, the same thing. It was more droughts back in 1100 around the medieval warm period than there is today. So everything they're saying doesn't stand up to science. If you really follow the science, you say CO2 is not the issue here. But that's not what we get pushed with. And if you look at, why is the Earth warming? And I don't disagree. I think we have been warming, but for different reasons. If this is the way the ocean looks like with an El Nino, a La Nina. So you have the winds drive all this warm water over to the west by Indonesia and Australia, and it gets stored down to 200 meters. This doesn't affect weather, but it's a store of heat. Here, colder water comes to the surface, and that causes fewer clouds and greater solar heating, which allows more heated waters to be pushed over here. When we get a El Nino, this stored water comes out to the surface and comes across, and you get less heating here in the east like you did from a La Nina, and you have the spikes in temperatures. If you look at global average temperatures, when this stored water is released during an El Nino, you see the temperatures go up. And it doesn't mean the Earth is warming, it means the Earth is cooling. If you look at the whole system, the air temperature is warmer, but the ocean is cooler until you go back to a neutral or La Nina condition. So, in just a kind of a general sense that you got solar heating, about down to 600 feet, it will warm the water. And then you have this quick drop off. And then below 3,000 feet is all this cool water. And part of the reason you have this cool Eastern Pacific is because this water that's from deep down is brought to the surface due to upwelling. That upwelling also brings nutrients and CO2 to the surface. So it's the reason that along the coast of California has a really dynamic marine biology. But it's that cold air also causes a high pressure system to set in, which causes our Mediterranean climate. It prevents moisture from coming to California during the summer. I get these alarmists who will say, well, CO2 is causing 90% of the warming. 90%. The warming that they predict from CO2, they say, well, we don't see it in the air temperature because 90% is going into the ocean. So you would think the whole ocean is absorbing heat, but if you look at this, and this is from I didn't study, Huang did this in 2019. Everything that's in the greens to blues is where heat is coming out of the ocean. The only places that are really storing heat going into the ocean is not global, but it's the reds and the yellows. And mostly right here where you have a La Nina, that's where most of the heat goes in. During the Little Ice Age, we had less, the oceans were more like an El Nino, so there was less heating of the oceans. Since the sunspots and the solar energy sort of picked up at the end of the Little Ice Age, these more La Nina-like conditions developed, which caused more heating in the ocean. And what you see is the warm pool over here started to grow, and it also circulates more heat to the north and the south and across in the ocean. And if you look at where most of the heat is coming out, the Arctic would be cooler if it wasn't for this transport of heat. You see, most of the heat that's coming out, that's warming the Arctic and warming the East Coast, is stuff that it was heat that was absorbed by the oceans down in the tropics. They have like a La Nina in the Atlantic, which is just not as powerful as this, and it gets transported to the north. So I said, well, it doesn't make sense. And I said, well, maybe this heat is because of CO2. Well, if you look at in the Arctic, all this warm Atlantic water, because it's evaporated and becomes more dense because of salt, you have all this warm water that's stored beneath the Arctic Ocean that can melt all the sea ice several times over. And when the winds get rid of the ice, this warm air comes up. They have noticed, they've made measurements between the 50s and the 90s, where there is perennial sea ice, you might have 2 watts of energy coming out from the ocean. If you remove the ice, you have like 40 to 50 watts. So a lot of the warming in the Arctic is due to this heat that's stored that's now coming out. So when we see warming in the Arctic, it's not that the Earth is getting warmer, it's that the oceans are cooling. And so you see that here was a temperature data from of 25 years. Cohen in 2014 showed this. North America and Eurasia are mostly cooling on average. You see in the Arctic Ocean, where hardly anybody lives, where the ice is sort of melted because of this transfer of heat from the equator, temperatures have had this dramatic rise, 2 times, 3 times average. And actually, that's if you average these together, it looks like the Earth is warming, but you're missing the dynamics that cause it. It's this transport of heat from the tropics into the Arctic. Well, one of the big things that also happened when I said, well, people are saying polar bears are going extinct due to this. And if you understand marine biology, if you have a lot of ice, you can't have very much photosynthesis. Productivity drops. The amount of plankton you have is reduced. The fish suffer. The seals that the polar bears feed on don't have as much food. And so the polar bears should suffer when there's more ice, not less ice. And if you people look at increased productivity, there's tons of studies that do that. If you just understood basic biology, you would understand this, but they've used satellite data to see chlorophyll. The Barents Sea, which is where you saw the most of that water come up from the Gulf Stream and up into the Arctic, its productivity is almost double. In different places where you have this inflow, the productivity is doubled. And this is why no one sees polar bears dying off like they do. We see them doing better than ever because we stopped hunting. And if you think about it, if you go back, and this is from data from Stein 2017, during the Holocene optimum for 10,000 years ago, far less ice. A lot of the glaciers were retreated much further inland than they are now. And we didn't really get a lot of ice until the Little Ice Age, just 400 years ago. So we have a little dip since then. But compared to what the polar bears have suffered, if there was supposedly an extinction of polar bears, it would have happened back then. But we're not seeing that. But if you don't get that kind of information, you get totally misled. They try to pull on your heartstrings of some, polar bear cub. Oh, this is what we're dying from. And also you have what's connected to these ocean oscillations. You get warm fish and warm water move into the Arctic and then retreat. If the Danish sea ice records here on the left, in 1937, the loss of ice, you can see the blue is open water, is almost the same as what they saw from in August 2013 of satellite the same kind of open water here and here. It's due to this flow of hot water going into the Arctic, not because of CO2. People that looked at where you had all this ice, where there was no heat coming out of the ocean, they said, I see no evidence of global warming. It seems like the greenhouse theory is wrong. And it's because the ice prevents this ventilation of heat. But you really don't see that in the discussions. And the other thing there's several different oscillations, but the Atlantic multi-decadal oscillation, where you get the northern hemisphere is a lot warmer than the southern hemisphere. And they think most of it has to do with the amount of heat that gets transported up into the North Atlantic. And the Atlantic is the only place where you have warm water that comes from the Indian Ocean, from La Niñas, goes underneath, it helps warm here, gets warmer around the equator, and then crosses the equator. The way the winds work here, if the winds work so they're a little to the north, it pushes all this warm water north. If the winds go a little further south, trade winds, the warmth will go back here. And what's looking like happening is pretty soon we're going to go to the negative phase, the cool phase. But you go to this loss of ice melt in the 30s, you have the heat waves in the 30s, everything else. This is also connected with when you had this warm period of a lot of warm water being pushed into the northern hemisphere. So it's, I think I've made a bet with a couple of physicists from UC Berkeley that we're going to see Arctic sea ice start to return by 2030 because these oscillations are going back to their cool periods. And if that's true, I hope I live to see it, that should shatter all this climate catastrophe. But we need something like this to convince people that are just blindly accepting all the catastrophes. Just a further data on this idea, this is kind of showing you get this warm water come up mostly to the Barents Sea where most of the sea ice is lost, but it also circulates. It might take 25 years so it's to circulate and then cool and come back. But if you look at studies that show how this heat has been transferred, you see that in the 70s, there was very little going up. And then it's been increasing up until around 2000. It's starting to cool off again. So we know this dynamic is going on, and it sort of fits what we're seeing there. You don't see everything. We say, well, is that hot water from CO2? Well, if you look at the very upper millimeters, and you said the tip of a pencil is 1 millimeter, 10 microns, and it takes 1,000 microns to make a millimeter, is what we call the ocean skin surface. Heat from infrared, from greenhouse gases, does not penetrate any deeper than this 10 microns. Once it hits that ocean, it stops. Where solar energy goes a lot deeper. So you see in the daytime, you get this warm diurnal layer because the sun heats the water much deeper. If you kind of look at the skin layer, the sun only heats that skin layer with about 4.9 watts, but it goes down to 10 millimeters, 1 meter, 5 meters. You're seeing hundreds of watts of heating going on. But if you look at infrared, it's only like at most 10 microns. And so the question of how can you heat the ocean if it's this 10 microns? And we see people, well, the turbulence could mix it down lower. But they had a study by Wong and Minette, and they were able to measure on a cruise how much long wave radiation from greenhouse gases were coming to the surface. And they measured about 410 watts per meter squared. And they go, how much long wave is leaving? And they had about 470. And as soon as this infrared hits that skin surface, it starts radiating the temperature, the heat back out. So it doesn't have time to really mix down lower, where all this solar heated water that's much lower has a much greater probability of mixing deeper into the ocean. And at the same time, if it's heating the skin surface, it's giving more warmth to the air, which is typically moving from the ocean to the air, and you have more evaporation, the latent heat. So the skin surface controls what's going on in the ocean. And if this heat that goes deeper than that doesn't reach the surface, it doesn't do anything to our climate. It gets stuck there, like we see during La Niñas until an El Nino brings it up. So this whole idea that CO2 is warming the oceans and 90% of it's there, I just don't see it. If you look at the science, if you follow the science, their story is full of caca, if I can say that. And we got to teach people some of these things. That's what I've tried to do with my videos, with my book. But it's a lot of people just, their eyes start to glaze over with too much information on weather and science. But I'd like to make it simpler, but I don't know how.
So what is the name of your book before we forget?
Well, in 2013, I wrote Landscapes and Cycles, an environmentalist journey to climate skepticism. And then most of it is looking at polar bears, the butterflies, penguins. I was seeing everything mostly as an ecologist interested in wildlife. And to understand that, then all my understanding of these ocean oscillations and physics, Will Happer read my book and invited me to join his CO2 coalition, and which I was honored. And I'm, because I didn't have a formal training in physics, but I did take a number of physics class. I knew it all had a fit. He said he gave me credit for knowing as much about the atmospheric physics as most of the people in his field, if not more. So I feel like I'm not talking nonsense. I feel like everything I say has been well-founded. Most of all this data I show you is from peer-reviewed published papers. So, it's just, how do we get people to see this? How do we get people to think about weather as natural, the extremes as natural, and not weaponize it for politics? So.
Very, very good. What do you think we're going to see in the satellite data in the next 30 years or so? Do you think that will show cooling then between now and then, or what do you think?
Yeah, what I think will happen, in part, if what we're seeing is low sunspot levels now that are approaching about what it was 100 years ago. Now, there's a correlation, and cause and effect is somewhat debated, but as we went into the little ice age, the intertropical convergence zone migrated further south. And when that happens, there was less transport of heat into the north. And so if that keeps happening, I think the ITCZ will start moving south. And so I think you would see less heat up there. I think you're going to start to see, if that happens 2030, I think you're going to start to see more sea ice form in the Arctic. And when you see more sea ice form, you're going to have less ventilation of heat. And it will take, if you look during the Ice Age, you had these things called the Dansgaard-Esker events, where like within 40 years, temperatures are raised 10, 15 degrees centigrade because this heat ventilated out of ice-covered Arctic oceans. And it kind of, it helped ventilate so we didn't totally go into an interglacial. So I think you can have, this heat get stored for a long time and cause temperatures to go down for a while. And that's, that's where I would put my money right now, is it's a lot of this global warming is being pushed by the Arctic heat ventilation. In terms of populations, if you devegetate areas, you urbanize areas, you're going to see warming in those places. And so you really have to be careful of what you're seeing. When I showed that picture of the Atlanta urbanized area, you see, 10 degrees difference between vegetated and urbanized areas. So you'll see that happen. A lot of the weather stations we have right now have only been in place since the 50s. So I don't know how good a trends they can really present us with. But, I tend to think that, I have a bet of a couple bottles of wine that we're going to see Arctic sea ice come back, because it's the dynamics of transport of heat, not CO2 warming, that's causing the issue.
Okay. And then what do you think is the climate sensitivity to doubled CO2, all things being equal?
Well, you see different, if I look at what Will Happer did with atmospheric, he looked at different places from the Sahara to the Antarctic. And he thinks that extra CO2 at most is going to cause a 1% increase in the amount of energy that's coming down to the Earth. But that doesn't tell you how the Earth's going to respond, where it's going to get stored. If you go above, moisture has a lot to do with it. So I think sometimes they conflate a higher temperature with higher sensitivity to CO2, when it could be a higher temperature due to less clouds causing greater solar heating, due to drier land. It takes twice as much energy to heat moist soil as it does dry soil. So if you get a drought due to La Nina, you can have dry conditions, and with no change in energy from CO2 or the sun, you'll see temperatures go up. So you got to account for those dynamics. So I could see in places where those kind of dynamics are in play, that satellite conditions will say, oh, look, there's warming here. But it requires people to go and look at those dynamics that cause that, not just say, oh, see, this is what global warming predicted, which is the knee-jerk reaction of most people.
So I think this is a good stopping point, but thank you very much. That presentation was really good. I totally enjoyed that. So,
oh, thank you.
And
I was waiting for you to interrupt me a few times, but
no, you're on a roll. So yeah, I'd love to have you back again some other time if you'd like to do that.
Tom, anytime. I think the more we can get the truth out here, the better the world's going to be.
Okay,
and
so
I appreciate all your efforts.
Thank you very much. All right, we'll talk to you next time. Goodbye.
Talk to you next time. Bye.